welcome back to the last panel of our day, day one of the UK IGF. And this will be the last panel before the wrap-up discussion. I hope you all enjoyed the panels this morning, as well as the networking session just prior to this panel. As you can see, this panel is called The Future of the Internet. And before a few points about how to use our platform, I will tell you what the panel is about and introduce the chair, who will then introduce the speakers. I'm Desiree Milosevic, and I'm the member of the UK IGF Steering Programme Committee. The panel today will look at the ideal principles for a global infrastructure for the internet. And it will also look whether these principles are up for purpose and what needs readjusting, and what are the different factors that might affect them in the near and long term. I hope all our speakers have sharpened up their crystal balls and will able to tell us what to expect as the future of the internet. If you'd like to ask a question, you can use the Q&A tab to the right corner of your screen. And if you'd like to chat to someone in person, you can do so, but I'm doing a private chat. So it's my great pleasure to announce and to present the Dr. Hussein Badran, who is the director at the Internet Society. His actual position is the Director for Internet Growth and Trust, and he's based out of Ottawa in Canada. Badran is also a member of the NANOG, or American Network Operators Group, part of their Education Committee. He has done many things in his long career, so I'm trying to mention also some very important ones, and that is that he has also co-authored a paper on infrastructure resilience, and he is at the Canadian Forum for Digital Infrastructure Resilience, which was established by the Innovation and Science and Economic Development Canada, ISET. He's also a co-author, as I said, of the final report of the Canadian Multi-Stakeholder Initiative on the Internet of Things Security, and it's called Enhancing the IoT Security. He has been a member of the steering committee of the Arab IGF since its inception in 2010, and he has been overseeing the program content for the annual event for the Arab IGF, and was the chair of the program committee for the Canadian IGF in 2020. And during his career of some 25 years plus, he has been as a C-level expert, and he spent 14 years with Cisco Systems as Distinguished Systems Architect and Regional Chief Technology Officer, and he was a member of the Cisco CTO office. However, before joining the Internet Society, he also spent 3 years as Director of Special Projects and Innovation at Qatar Computing Research Institute, a member of Qatar Foundation in Doha, Qatar, where he led projects dealing with machine learning and data transportation, e-health, aviation, and cybersecurity. He also worked with Nortel Networks before became Nortel. But to stop here, we can go on. I'll give the word to Hussein Badran. Welcome, and the floor is yours to start the panel and introduce the speakers.
Thank you so much, Desiree. Good afternoon. Thank you so much for the very kind introduction. I appreciate the effort, and thank you for the UK IGF for putting together this excellent panel, excellent topic. Very honored to have the panelists on board. It is my great pleasure to introduce to the panel Lisa Four. Director General of the European Telecommunication Network Operator Association. Lisa has been with ETNO, with ETNO's Director General since January 2016. On behalf of the association, she is also a board and an administrative committee member at ESCO, the European Cybersecurity Organization. Prior to joining ETNO, she was Chief Operating Officer of DK Hostmaster and DIFO, the company who was managing the .k domain. She also chaired the cross-community working group for the IANA stewardship transition. And Lisa has 20 plus years of experience in telecoms industry. She started her career with Danish Ministry of Science and Technology and Innovation. And she also worked for Telia Networks, leading telecommunication network operator, where she led various streams dealing with issues of diverse as interconnection agreements, mobile services, and industry cooperation. Welcome, really, Lisa, to the panel. It's an honor to have you on board. It's my honor also to introduce Elisa Cooper. Elisa is the Vice President of Technology Standards and a Fellow at Cisco Systems. Her work advances the state of the art at the intersection of engineering policy and technical standards. She previously served as Vice President of Technology Standards at Cisco and in a variety of leadership roles at the IETF, the Internet Engineering Task Force, including serving as the chair of the IETF from 2017 to 2021. She also served as the chair of the IANA Stewardship Coordination Group from 2014 to 2016. Prior to joining Cisco, Elisa served as the chief computer scientist at the Center of Democracy and Technology. And Elisa holds a PhD from the Oxford Internet Institute and master's and PhD and bachelor's degrees in computer science from Stanford University. Welcome on board, Lisa. It's an honor to have you on board.
Thanks for having me.
And last but not least, it's my great pleasure and honor to introduce Alain Durand. Alain is a principal technologist at ICANN. Alain currently serves as principal technologist at ICANN, where his responsibilities include applying expert technical knowledge and experience to improve ICANN's technical capabilities and stature. Alain has done extensive research into non-IP networking and new IP, and has past experience of working on IPv6, as well as in working with various entities using IP for communication. Welcome on board, Alain. It's an honor to have you with us.
Thanks for having me today.
Thank you so much for joining this panel. As the title says, looking at the future of the internet, basically a crystal ball, but it's based on the experience that we have built deploying and managing the internet for last decades. To start with, we have a question that really is in many people's minds. What are the ideal principles for global internet infrastructure, and how will they feed into the process of developing future policy? So basically, what are the key ideal principles that the internet has been based on that makes the internet today so successful? If I may direct the question to Alain first, to share his views on this topic, that would be really, really great. Please, Alain.
Thank you. In my perspective, the number one characteristic of the internet is not the number of users, it's not the speed at which we can connect. It is the openness character of the internet. The fact that anybody can connect and anybody can deploy any applications without having to ask any permission to anybody. That's what we call the permissionless environment. And this is a very, very important characteristic of the internet. Back in the early 1990s, people could set up websites not having to ask anything to anybody. It was actually extraordinarily simple. Just get some software, compile it, running on a workstation, done. And that's how this thing, now we call the web, got to come to life. If we had to go and ask permission to a network operator, to a government, to some kind of coordination body somewhere, this will never have happened. And sure, the architecture of the internet has changed a lot. We can talk about end-to-end principle. We can talk about where are the ends, what are the edges of this thing. We can talk about the evolution with content delivery network and other things. But still, this openness principle is really what remains and defines the internet. And I think that's a value that we need to cherish. I'll pass it on to other panelists.
Thank you, Alain. That's permissionless innovation is certainly key. Elisa, if I may jump to you, perhaps your views and perspective.
Yeah, I think that was a great place to start because in a way, all of the architectural principles that underlie the success of the internet to date come back to this notion of permissionless innovation. They kind of build together. I think if we pull them apart a little bit, you can see some sub-principles there. So one that I like to emphasize is decentralization, that there isn't a centralized authority telling us how to design new networks, and that there's really a very minimal set of core protocols and infrastructure that binds the entire thing together, but that's really kept to a minimum, and that allows independent network operators to run their networks as they see fit. It allows independent application developers to create new ideas, launch new services in ways that are interoperable, which is obviously the key to building a global network, but that are decentralized in terms of their operation. And I think that when you compare to, the telephone network or the electricity grid, you really start to see how that decentralization allows for a much more rapid pace of innovation. The other one that I would emphasize is around the incremental nature of this innovation. That this may not have been true necessarily in the 60s and 70s when it was first conceived, but certainly is true now that we have a gigantic amount of infrastructure that is involved in the internet. We have billions of nodes. We have tens of thousands of independent networks that are interconnecting. And so the fact that we can continue to evolve and change this network in an incremental fashion, that it doesn't require a forklift upgrade or a wholesale change in order to accrue new benefits and make improvements in the everyday experience of internet users is both critical to its future success and also a reason why it has been able to sustain so many different kinds of new technologies coming onto the network. So I think those three really go together: the permissionless innovation, decentralization, and incremental nature of its evolution.
Yeah, Elisa, these are certainly quite critical points to the critical nature of the internet evolution. And Lisa, perhaps your perspective coming from the business community, what would you, please?
Thank you, Hussein. And I'll take it from a slight different angle because Elisa and Alain took it from a very technical angle, which is, I find, is of course one of the key functions of the internet, that we need to have the focus on the technical part. But if we look at the internet as it is today, it's run on a multi-stakeholder model way. We have the open innovation, which is important for the internet. And that's a bit back to what Elisa is saying on the decentralization, which is a super interesting way of allowing for innovation all over the world. But this again implies that we need to have a strong focus on who's actually participating in the innovation and development of the internet. So that brings me back to what we see right now. We have an internet that works very well during the pandemic. We all took the shift from workplaces to homes, and it was still a good and solid internet, of course, depending on your connectivity. But the internet proved that it was actually able to live with a strong and a change in where people were connecting from. So what we see is a good internet that is now also developing. what I see is more than ever, then standards and standard organizations are becoming more and more political. And to me, this creates some issues, because we need to make sure what's happening on the technical level reflects what you need to have on the political level. And we need to make sure that these two worlds are communicating. So we have a lot of very good standardization organizations that are extremely good of having the multi-stakeholder model, making sure everyone are open and free to participate. But we need to make sure that the political level, the commercial level, understand what's happening on the technical level. So to me, what we need to do in the future internet, and I see this becoming more and more apparent, is that we need to make sure there's a bridge between the political and commercial level and the technical level. And because our world is becoming more and more complex, and things like, we're going to discuss it later, new IP, DOH, and also Apple's private relay, we have a lot of technical changes on the internet that will influence the way we use the internet and the way we access the internet. And I think it's important we make sure that whatever we talk about on the technical level is understood by all the normal users of the internet. I'll pause here.
Thank you so much, Lisa. And you brought up some critical points. Some of them we'll discuss in the later part of the session, as you mentioned. Perhaps just to continue with the segue that you have provided, I wanted to mention that at ISOC we also looked at the critical properties of the internet, and we have. One of the critical properties we identified is having this common architecture, the common protocol that is used across the internet, an open architecture of interoperable and reusable building blocks, and common global identifiers that can be used across the internet, even if as you know, internet is based on many heterogeneous networks interconnected together. But one other key principle is that the internet is based on technology neutral general purpose network that is accessible infrastructure with a common protocol, as I mentioned. Perhaps to build on these points that we have mentioned, looking ahead, what current technological drivers and developments are likely to affect this architecture in the near term as well as in the long term? So perhaps I could start here this point with Alyssa. So what do you think are the key components or technological drivers that would and developments that are likely to affect this global internet architecture in the near term and in the long term?
Sure. So I think there's a few of these that come to mind, and in part, I tend to think a lot about the lived experience of what we've had with building the internet in the recent past, and that I think influences future predictions. I hate making predictions, by the way, so I'm very much grounded in like what are we actually seeing today, and in the short term future, what do we think we're going to see? But I think there's obviously been a tremendous amount of focus in recent years on hardening the core of the internet and providing baseline security in the protocols and services that are offered in a way that users don't have to think about it. They don't have to be involved in configuration. They don't have to be looking at user interfaces in the browser to determine if something is secure or not. It's just on by default for everybody, and it works. And we've made great strides in that area, and I'm happy to kind of illustrate that more later in the panel if we want to. But I think building off of that, I think we're seeing some technology developments now that can bring some of those same gains in the area of privacy. And the reason that I'm optimistic about this is because the way the internet has grown and developed, we now have tremendous content delivery infrastructure that's out there. If we look at all of the big CDN providers and just the amount of network and server capacity that's been built all around the world in order to deliver content and make applications perform better. And if we start to think about that infrastructure as a proxy infrastructure, as a means to make use of these content delivery networks to actually deliver privacy benefits to users, I think we're going to see a huge explosion in that space. So we're already seeing things like oblivious DNS. There's new work at the IETF around oblivious HTTP application intermediation, where we use this infrastructure to shield the identity of users on the endpoints from the servers that they're trying to reach. We use this proxy infrastructure to strip out that identity information, and so that you can do things like DNS, things like measurement and telemetry in a privacy preserving way. So I think we've seen, as I said, a huge revolution in security in terms of the baseline that we have in the core of the internet. And I'm hopeful that we can use some of the architecture out there that's been built for content delivery to do the same thing for privacy. Together with that, I think we're also seeing independently some innovations in the security space that that will continue to deliver benefits. Things like secure multi-party computation, where we take the different parts of a computation and spread them among different parties, so no individual entity is able to recompute a final result, but you have to have collaboration amongst them in order to obtain a result, and whereby we can do these kinds of computations with cryptographic verification, such that we can prove the security properties of a computation that we're trying to do. In my view, basically all the new hard networking problems are actually security problems, and so I'm optimistic about new kinds of security technologies being applied to networking problems. And then the last one that I think is already underway again, but I expect to continue, is just looking at how we can better leverage automation to adapt to changes in traffic flows and where traffic is located and where it's being processed. So we see a tremendous trend with workloads moving from the center of the network to the edge, with edge computing, dynamic applications that are ambivalent about where the work that's happening to produce those applications occurs in the network. And I think as we see that dynamism and traffic moving around and not only being centralized in one location, we're seeing lots of adaptations in terms of how we manage traffic and how applications are designed. And I think developing better ways to automate that and to provide tools for application developers, because they do not want to have to think about how their traffic is routed, how they're configuring routes, how they're doing traffic management, right? Your average application developer today wants to not have to think about that. And I think there's likely a revolution coming in automation that can deliver those benefits to application developers and continue to speed up the application innovation process.
Thank you, Elisa. Yes, certainly the areas of security. I'm very happy to that you mentioned the advances that are taking place at the IETF and other places, as well as network automation, are certainly key for the future evolution of the internet. Lisa, if I can come to you and see your perspective on the future developments that could impact the evolution of the internet, in your view?
Yeah, in my view, I see two trends. And I agree with Elisa that that we see a lot happening in the security field, and this is extremely important, because without the trust in the internet, we're actually not going to use it. So from my point of view, I'm not against security. But I see a lot of things happening in a way so you centralize the traffic into some traffic streams where kind of the stripping away of the identity and the privacy makes it also difficult for some of the operators to comply with legal requirements. In Europe, we had the NIS2 directive that that forces us to be able to track traffic and by legal interception give information to the authorities. But and part of what we see is happening is that some of the security implementations makes this harder. One is the DOH that can be implemented in several ways. It can be implemented so the operator can comply with the regulation and still secure the user, but it can also be implemented in the browser where we will be blind, both for where the traffic goes, but also who's actually the addressee of the traffic. This creates two issues for us as operators. One is traffic management. The other one is the legal requirements. But just understand me right here. I'm not against security nor privacy. I think it's extremely important. We just need to work together to implement it in a way so everyone can comply with their technical part of the ecosystem. And I also I see a greater concern on some of the privacy requirements. Europe is a bit, if we look at Europe as an example, we have some very strict security and privacy regulation. And part of it is good for the end users, part of it is annoying. The cookie regulation is an excellent example of something that's utterly annoying and everyone hates it. So we just need to find better solutions for this. That being said, what I also see is that whatever happens on the political level influence how things are being done worldwide, because Europe is not an island. So whenever we have a requirement, it's sometimes reflected and mirrored in other parts of the world. So I see the internet has always been global and open, but I also see now that it's becoming more regulated somehow, and also more ring-fenced by some technologies that creates issues for other parts of the ecosystem.
Would you like to give an example of these technologies that create problems?
Yeah, well, again, like the DOH is ring fencing part of it. I see Apple's private relay can risk ring fence it because it creates also some single point of contact and failures, and it centralizes the traffic. I'm not saying this is all bad. I'm just saying we need to have a stronger a stronger communication, dialogue, and joint innovation in how we avoid these becoming annoyances or risks for the users instead of helping the users.
Thank you, Lisa, for raising these concerns about implications of particular implementation scenarios, how they can affect the usability of the services and making compliance with the regulation. Alan, would you like to provide your perspective on the future technologies?
Sure, and I would like to take it maybe slightly to a different direction. It's about users. And as you mentioned, it's about making sure that all the users in one place can communicate with users on the other place. And users could be human beings, they could be machines, but at the end of the day, those are about users. If you focus about human being, we all speak English here, but my native language is not English. My wife doesn't, well, she speaks English, but it's certainly not a native language. And there are a lot of people on the planet who don't even use the ASCII character sets. They use their own alphabets. And right now, using your local language, your local character set is still a struggle. And a lot of work still has to be done to make sure that they can very easily use their own environment, their own language, their own character set to communicate with other people. It is really not easy. For example, if somebody send me an email in one of a local dialect in some other countries, it's going to display maybe not on my screen. But if I want to respond, my keyboard will certainly not be able to type any of those characters. So there are a lot of challenges to be addressed there. If we talk about those identifiers, that's a crossroad also with privacy. A lot of the identifiers we have now are more or less persistent. They at least last several days, several months, not really years, because after several years, all the URL break, we all know that. But they last a long time, and that has a potential for user tracking. If I have a device, an IoT device that is in my pocket that has an identifier, and this identifier remains the same for a couple months, and I move around, by simply tracking this IoT device, you can track exactly where I've been. So finding ways to provide identifiers that will have a short duration life, that will only be valid maybe for an hour. And if I use this device in one context and I move to another context, maybe I should shift to another identifier. So those ephemeral identifiers is a direction where I think need to be developed a little bit further. And that actually brings me to a third topic, which I will frame it as a risk. It's a risk of fragmentation. There are different technologies that are being proposed that are trying to push the internet in places where we no longer have this incremental deployment of technology that Alisa was talking about earlier, but we may have some disruptive changes with different type of identifiers that may or may not be compatible with what we have now. And that has a potential to really splinter the internet in different places. If we look at the development of access technologies, things like 3G, 4G, 5G, in the last, 20 years, every time it started, it was like a brainstorming session. Everybody has a great ideas. We are going to do all new things, all new kind of usages. And at some point, it converged. Why? Because all the participants in this system, being the vendors, being the service providers, being all the people in between, they had a vested interest to have a single solution in the end, so it can be deployed everywhere. So yes, it started with lots of different ideas, some maybe more or less crazy, but in the end, we got one solution. Now we are entering definition of 6G, and it is less clear if the same impetus to have a single solution for this will remain. And there are concerns that in different parts of the world arrive with different technologies that may be incompatible, that may or may not use the same unique identifier system, that may or may not use the same governance model behind them. And that's a real concern that could really, really splinter the internet. And that's perhaps one of the things that keep me up at night those days, beside my baby.
Thank you. Of course, the baby has first priority, so that's very important. I wanted to thank you for these comments, and particularly on the points of the potential risk for fragmentation. The reason is that there's a question from the floor that came in and seems to have acceptance from the audience, and I wanted to perhaps pick the brains of the rest of the panel. So that the question is: do the panel share concerns that the ever-increasing centralization of key parts of internet infrastructure? Do they agree that this process poses risks to resilience, privacy, and innovation? So this kind of centralization, increasing centralization, there's a concern about it. The question is to the panel: do you, Lisa and Lisa, see this as a major concern, or what is your view? Lisa, please.
Okay, I think Lisa wanted to go first, but I'm happy to speak first. So I think it's important to look at the underlying economic drivers here. So when I think about this, I think about it from the perspective of consolidation of market power in certain technology markets. And if you look at it that way and think about economies of scale and network effects, you start to see these, very traditional, well-studied dynamics from the economic literature that are playing out in specific technology markets that lead to this, consolidation of market power among large technology companies. And so, to me, that's the lens through which it makes the most sense to try to reason about this issue. I think there's a lot of push to look at, or at least in the IETF, I will say, there's been, push to look at had we designed the protocols differently, would we not have ended up in the situation that we're in? Is there something that we did when we, set out to document how are we going to build this DNS, or how are we going to build this email infrastructure or this web infrastructure that that created this situation where we have a smaller and smaller number of larger and larger players? And I just don't buy into that view that this was a technologically determined outcome. I really feel that this was a market driven outcome based on those kinds of economic effects. And as a result, I think what we need to think about in terms of mitigations largely come from an economic regulatory perspective. So it's, I think, been, at least from my personal view, it's been welcome to see regulators around the world waking up to the effects of this consolidation and starting to think, very critically and collecting a lot of detailed evidence about market power dynamics in specific markets. I think that's sort of the path to addressing these issues, as opposed to thinking about it from, if we would just redesign this one protocol, are we going to get ourselves out of this? Because I don't really think that's not the playing field that we're in when we think about this issue. I do think within standards organizations and other technology fora, the participants need to be aware of these dynamics and consider that when we're looking at how do we come to an outcome, how do we come to a consensus decision about a standard. But I don't think that should be really the driving factor to say we should or should not standardize something, because it's going to, it's just going to benefit this or that large entity at this point in time. We live in a world of large entities, and they're going to, benefit or not as they see fit. So I don't think that should be the driving factor from a technology perspective.
Thank you, Alisa. Appreciate your point of view. Lisa, please. I'm sorry to not pick on your picture before.
Oh, don't worry. It's fine. And actually, I share and don't share the views of Alisa on. I agree from the beginning. The technical and the protocol features were not meant to create these big players or big platforms, and the internet was more meant as this open infrastructure. And but I see now is that some players are introducing technology that actually risks centralizing things. And it's now that you have technologies and how the big players actually develop their markets, and I agree we cannot turn back time, but I think for the future we can make sure that we avoid creating a more centralized system and bigger platforms and fewer players. I think what we should aim for is nurturing the openness of the internet, and that all players should have equal access to the internet. I know that's not what you're talking against, Alisa. I'm just saying that I think technology now needs to be vetted against what is the effect on the markets of this technology, because I think now we are at a point where you cannot separate the two. Whatever you do in the technical field actually has a commercial implication and political implication. And we need to take all these three into account. It would be wonderful if we could separate policy from technology, but I think it's extremely difficult. But going back to the standard organizations, what I think is important you do when you talk technology there is that you include as many technology organizations as possible. Because I look at Europe that has ENISA, that is working on technology of security here. You have IETF that are working on the protocol. I see we have a lot of standard organizations that need to be talking to each other and making sure that we're not doing one thing in one standard organization that's creating a fuss in another part of the technology area. So it might be a bit fluffy, but I'm not deeply into the technology. But from a political viewpoint, I think it's important when we talk about the multi-stakeholder model, we also see all the organizations that are out there and make sure they are all around the table.
Thank you, Lisa. And this is really an important point, and it's basically a segue into the second part of the discussion regarding standards, organizations, and proposals there. But before we go there, I wanted to acknowledge and thank the UK DCMS for proposing this session to the UK IGF organizing committee at the future of the internet, and they know they have, I believe, a task force looking into this this kind of direction, and I welcome their participation from the floor. If they have questions or comments they would like to share with the panel, please do so. Without further ado, we'll go to the second part of the discussion, where we just were introduced to the topic of international centralization, and I would like to ask the panel on their views of the current proposals being submitted to international standards organizations like the ITUT, aiming at developing new architectures and models for the global internet, and what would be, in your view, the possible implications of such proposals on the global internet architecture and model? If I can, of course, new IP is the key acronym here. If I can start with Elisa, please, and then move to Elisa and Alain. Thank you.
So, Hossein, I was going to talk a little bit about how we think about the costs of these new proposals. I wasn't sure if Alain is going to talk about the kind of the technical impact. Then maybe he could go first. I'm happy to do it either way, but just wanted to check. Sure. So I know Alain has written extensively about this, so give him the floor. I'll follow up.
Excellent. Thank you, Elisa. Please, Alain. Excellent suggestion.
Thank you, Elisa. So, for sake of time, I will be brief. We saw some proposal coming at ITU, and first thing to really stress is those are not ITU proposal. Those are not something that has been blessed by or adopted by the ITU. Those are some companies that came there and some different study groups and made those proposals. Those proposals are not completely documented anywhere. So this is not something that is a standard by any way, any stretch of imagination. You cannot simply go and try to implement these things today. So when we are comparing something that is essentially a list of ideas with what the internet is today, this is not a fair comparison. Still, there are enough hints in different presentations, in different papers that have been written about that, to understand some of the challenges there. Essentially, if you look at this new IP proposal, this is about giving a stronger role to the nodes in the middle. In the internet architecture, essentially the routers, nodes in the middle, they have very little to do with the communication. Their job is to move packets around as quickly as they can and pass the traffic to the next one, and that's it. Here, we're talking about reserving specific bandwidth or specific delay or jitter, and starting to put state into all those different elements. So when you start to do that, it becomes more complex and it becomes brittle. But there are also some challenges with that. When you start to reserve resources, you need somebody to pay for those resources because they are not free. You have a finite amount of bandwidth, and if you slice it in a certain way, you give it to somebody or not somebody else, somebody has to reconcile it at the end of the month and pay for it. So you need to actually attribute to whoever is using this the share of the cost of doing this. How do you do this? While using cryptography. That's the only way. You need to strongly authenticate all the different traffics. It means not simply from, oh, I have a customer from this ISP. No, it's customer may be a company and there may be multiple people behind that using the service. Or if it is at home, I may have multiple parties in my home, and some of my children may or may not be allowed to actually reserve tons of bandwidth for their game. And if I want to watch a movie, I may be willing to pay for that. So it's really, really fine-grained authentication that needs to happen. And that needs to be checked on every single router where this traffic is going to go through. What does this create is create a control point, not just at the edge of a network, but everywhere in the network. And this is something that we never had in the internet architecture. We always had, as I mentioned earlier, routers' job was to pass the packets around, and that's it. Here now, we have a lot of flow points where you can enforce now external policies. And some of the papers that were presented at ITUT were talking about population control. Creating something in the architecture that will allow for something like that, population control, is a very risky proposal. And with that, I will hand it back to Alyssa.
Thank you, Alan. Yes, these are certainly key concerns with the proposal submitted to the ITUT in December 2019, and were debated until December 2020, when it's decided not to talk about them anymore and refuse or reject the new proposal for standards. But they still keep coming and come into under different names within the ITUT study group 13 and 11, which I have the pleasure to participate in. Lisa, from your point of view, regarding these proposals and their impact on the network architecture, I know that ETNO was quite clear and specific in its submission to study group 13 chair. Please, your views.
Yes, from our side, we think there are two issues with this proposal. One is the technical side that Alain has explained, but another thing is also this is a proposal coming from not a multi-stakeholder request, but more one player asking for another way of building or structuring the internet. I think this takes away the important abilities we have today of innovation, of using of the decentralization that's been discussed by many, but also there is a risk of better controllable internet, which has, of course, some good sides if things are bad things are happening out there, but it also has a very high price on all the rest. So I think what we need to do is to look at the internet we have today and just keep having the incremental changes here. So from our side, we find that we shouldn't change the model, and we still support the multi-stakeholder model and the internet we have today. So we strongly advise against it, and was very supportive and very happy that the European Commission came strongly against this proposal too last year.
Absolutely, thank you. Yes, the European Commission, along with like-minded states, were quite clear about their opposition to this kind of proposal, which has the risk of fragmenting the internet. So internet fragmentation is one of the key concerns as consequences in introducing such new protocol stack as a global internet architecture to replace existing IP-based global architecture. So the network fragmentation was a key concern. Another concern that was also mentioned, and that what Alyssa really will be of extremely high value to contribute on, is the cost of such a deployment of a new architecture. Alisa, what would be your point of view?
Yeah, I mean, I think the introduction of these proposals has catalyzed some thinking around a more generic question, which is that if you were to develop a non-backwards compatible, non-interoperable network layer technology, and you wanted to get it deployed at anything close to the scale of the IP-based internet today, what would that cost? And you know, it's easy as an engineer to kind of sketch out new protocol designs on a napkin or even in a contribution to the ITU or another SDO without having to think too hard about this. But from a vendor perspective, from an operator perspective, when it comes down to saying, oh, this might be a real technology, and if I wanted to deploy it out on the network, what does that look like in terms of the cost? And so I think thinking about that generically, not necessarily specifically for new IP, but a new non-interoperable protocol that's meant to deliver some kind of performance and security guarantee, what would the cost elements be? So I think there's a few of these to think about. You can think about the direct costs: new routers, new switches, new servers, new user equipment. Like all of that would need to have a new network stack. And given that at the beginning you have lower scale, your economies of scale are limited. So the equipment prices compared to something comparable that you have on the market today would be higher because you don't have as much equipment out there. You also have to think about the idea of an internet that's 50 years old, and we've been testing and refining and improving that and gained so much experience with what are the kinds of operational mistakes that happen, what are the kinds of errors that you have to anticipate, what is the security exposure. We have so much experience with that on the internet today that we don't have with something new IP like, or something that is yet to be deployed. So there's a whole other set of direct costs involved with discovering new vulnerabilities and new management techniques for this new network. And so if you think about all of that, there's like a lot of R&D that would need to go into the development of this new equipment and testing of it. And you can compare to, say, a company like mine, Cisco, where today we invest $6 billion a year in R&D for the IP-based network. So if we're thinking about multiple times over what you would need to invest in something entirely new, that's like billions and billions of dollars, even for an individual company to be investing. The other thing to think about, as Alain pointed to, is this notion about gateways. It's not just replicating the existing equipment that you have in the network, but you need these new gateways, and these are complicated gateways. These are not simple forwarders, because if we're doing address translation and protocol translation, that's a complicated system and potentially very fragile. And again, we have an analog. We can look at carrier grade NAT, this wide scale address translation that is done on the internet today due to the exhaustion of IPv4 addresses. And you can look at, there's published figures that operators have put out there about how much it costs to operate a carrier grade NAT. And that's in the hundreds of thousands, if not millions of dollars per year for certain operators, depending on their size. And again, we multiply that times 4, 5, 10 because of the complexity of these new gateways, and you can quickly see a large expense associated to the gateways. And then we have to think about connecting these networks. So interconnection is expensive. It's already expensive today on the internet if you're doing direct fiber interconnection, which is already limited by its cost. Things like transit. So if you're going to be parallelizing your transit, you're going to have IP transit and new IP transit. You're potentially doubling your costs or even more so, because you have to develop a whole new transit network in order to interconnect different networks speaking different protocols. So that's another additional expense to think about if we're thinking about scaling up a new protocol to global scale. And all of these costs really need, if we're imagining new protocols that have these improved performance guarantees in particular, these costs need to be borne before the first network can be deployed, because there's no advantage to you to deploying this and only speaking it yourself. If nobody else, if you speak new IP and nobody else does, then you're not gaining these performance advantages that are contemplated. And that means that the first movers need to internalize all of those costs before they realize any benefit from it. So it's a risky investment as well. And then the last thing I'll say is, Alain kind of previewed this. If we think about an endeavor like this, it's not about comparing today's internet to what this future protocol might be, because that future protocol is going to take a long time to develop. Let's say it takes 10 years to develop, then we're comparing the internet 10 years from now to what this might look like. We're not comparing today's internet, and that implies a real significant opportunity cost. So let's say I worked at an operator. I can have my engineers, I have 10 engineers. I can have them be working on developing and evolving the IP stack, or I can have them be working on this new thing. And all of the work that's diverted away from evolving the IP stack is a loss to the existing installed base. And so particularly for emerging markets, this could potentially have an outsized impact, because they're having to make difficult decisions between whether they invest in evolving something that they already have a baseline infrastructure today, compared to something that doesn't exist yet. So those are just kind of some of the cost elements to think about, whether it's this proposal that we've seen, or the next time somebody proposes replacing the internet with something new. I think there's a good framework there for thinking about the cost.
Absolutely, and I think these are very critical points to keep in mind when we are considering these kinds of proposals, and at standards organizations or at other fora. And one of the other related consideration is the business case for deploying such new architectures. Is there market demand? Is there user requirement to these services or architectures that are being proposed? Or are we developing a standard for the sake of standard, or for other purposes, like Anand mentioned, on geopolitical basis, or population control, as was eloquently mentioned? So the business drivers are key, also to consider. Looking at the time, and looking also at this discussion, what would you say the current processes that are taking place for shaping the architecture of the internet? Can we make them? Do they need to become more inclusive and involve in a more diverse range of stakeholders? Is that something that would help evolve the internet in a more inclusive kind of proposal approach? And I leave it open. Lisa would like to start, or Alain would like to start?
Lisa, please.
Okay, yeah. No, this is one of the things that lies close to my heart, because I think we should involve more stakeholders in all of this. And I think one of the issues we're having is that we might have a multi-stakeholder model, but it has its flaws, because we still need to bring those who can't afford to come themselves to the table. I know there is a lot of things going on where ICANN and other associations try to bring and fund all the stakeholders all over the world. But I also think we still need a stronger user representation in the more technical communities, like IETF and also ENISA and others in Europe. So it's more a matter of, if we want to make sure everyone is understanding the influence and what is happening in the technical layer, we need to have those discussions, but brought to a level where everyone understands them. I'm not saying we should refrain from having the very technical ones, but I know RIBE NCC has a government day sometimes. So I think that's a good initiative. You actually bring in the government to discuss the technical parts. But if we want to avoid a fragmentation in the future, we also need to be including all parts of the world. And I know there are different parts of the world that would like to have more control with the internet than the rest of the world. And we need to have those dialogue in an open and transparent way, and try to see how we can avoid what Alain was referring to as his nightmare, a fragmented internet where we are not all connected.
Hossein, you're muted.
Yes. And then would you like to add something to what Lisa mentioned?
Yes, I wanted to allude to another challenge that I've seen the last few years is when I go to some of the standard bodies meeting, I tend to see the same people. For the last 20 years, I've seen mostly the same people. And the question is, well, I'm not very young anymore. I may have a baby, but I'm not very young anymore. And what about the next generation? And one of the concern I have is the barrier of entry for the next generation in the technology area, not so much in the policy development, but in the technology area, is getting higher and higher. And how to get those people first interested, because sometimes this is it's a pipe, it's plumbing, right? It's not sexy. It's not like this nice fancy application gaming and all of that. How do we get those people, those younger people, interested in that? And how can we ease their learning curve so they can be effective at understanding the technology, at bringing new ideas, and at being the leaders for the next few years and replace us, because we are all dinosaurs.
Very solemn argument. Thank you. Elisa, would you like to add?
Sure. Yeah. I mean, maybe just some responses to both of those things. I would say it's just speaking from the IETF perspective. I think it's true that there's lots of people who are around who've been around for a long time, but there also are a lot of new people. Um, and to your point, Alain, I think part of the way that we have attracted and incorporated those people is by doing work that is relevant to what they are actually building and engineering on the internet today, and doing it in a style that is similar to how they are developing those things. So if we look at some of the recent larger security and transport projects in the IETF, if we look at transport layer security, or we look at our new transport protocol quick, we had dozens of implementations that were being built alongside the standard. And we basically just pulled those implementers in to say, hey, you're out there building the software. Can you please come help us improve the standards as well at the same time? And we built this feedback loop between the developers and the standards writers, whereby they would go and test a new feature in the software and then bring it back into the standards organization and say, here's what we found. We think we need to change this, or we need to improve that. And we use similar tooling, GitHub and pull requests and so on, to make it familiar for them, so that it was a way that they knew, a set of tools that they were familiar with using. And so in that way, we have pulled lots of new people in, even if it might be, at the beginning, just for narrow projects. Once, you drink the Kool-Aid, and then we pull you in on other things that might be a little bit further outside of your purview. And so I think expanding that kind of approach in other areas, I think in the IETF, it's been very successful in security and transport and applications. And I think the next big task is to replicate that in some of the more hardware focused areas, routing and layer 3. And I think, just to your point, Lisa, I do think there's a very important translation function that happens. I think it's very difficult for people who are not steeped in the technology to fully participate in the development of a new protocol, because at the end of the day, it's being decided on the basis of technical merit. But I think on the IETF side, that's why we rely on organizations like the Internet Society to provide some of that translation and bring policymakers in. And they've run a very successful policy program at the IETF for many years, whereby leaders in different government agencies from all around the world are brought to IETF meetings to learn about the process and hear from some of the technical leaders in the space. And I think to the extent that those efforts can be expanded or just further leveraged in other parts of the world, I think that's kind of a good model. I think it's too tall of an order. Even governments, even when there are people who are technical, they just don't have the resources to be able to cover IETF and 3GPP and ITUT and everything else that's going on. And so I think having those organizations that can provide a translation layer is extremely necessary.
Thank you so much, all, and thank you so much, Lisa. Actually, the last points cater very well to one of the questions that came from the audience and have taken a high rank in terms of approval, and it has to do with the role to help policymakers understand the hidden frontier of the internet, of internet governance and standards, etc. So, what would be, in your opinion, what should world leaders be doing to complement but not co-opt technical forums? There's an additional perspective that we can add here. Lisa, please.
I think governments, I understand there is a difficulty in participating in all these technical standards meetings and having the capacity to both translate it into what it means commercially and politically. But I also think all governments need to pay a closer attention to what's happening in the field of standards. So I think this is a two-way. I appreciate that IETF is doing this translation together with ISOC, and I think it's extremely important. But I also believe that if we don't have active participation also on in the meetings from the governments, from the users, we kind of lose that angle to any development in the internet and also in the future internet. And if you look at the importance of the internet for all of us, it's growing. Even with Internet of Things, it's becoming even more important, whatever we do here. I just cannot underline enough how important it is that governments become more active in this together with the users, because I see a lot of from the technical community, a lot of companies that are in the technical field are extremely good at this, and we have to rely on their transparency and respect of the multi-stakeholder model. And I'm not seeing a problem here arising right now, but it could in the future, unless we actually are involved, all of us, and participate on an equal footing here. So I'm saying governments to become more technical, users to become more technical. It's a dream. I don't know if it will ever happen, but that would be the ideal world for me.
And on that same direction, the next question deals with also, it says how can we, in our perspective role as industry, government, etc., ensure that other stakeholders are able to engage in the multi-stakeholder process, supporting technical evolution such as in SDOs. So how can we in our roles ensure that other stakeholders are able to engage in the multi-stakeholder process? Is that something that we can help with, or how?
So, I mean, just one idea building off of what Lisa said is, I do think there's room for a stronger partnership between private industry and government, and it depends where you are in the world. But it is the case that we like to see standards being private sector led, and that really the way that you want to be, defining that the cutting edge is via the great new innovations, and for the most part, those are coming out of private industry and not from the public sector. But that doesn't mean that government leaders can't rely on a tighter partnership with private industry to gain more information about what's going on, what's coming down the pike. You see this with the generations of the mobile standards, right? So in some countries, there's a well-defined process for trying to feed in what that country's interests are into 5G or 6G or what have you. But it need not be limited to those domains, and there's probably more room for that in more different parts of the world, to just as the previous question teed up, not have it be co-opted, but just have more information sharing going both ways, so that industry understands what the priorities are of government, and government understands what the priorities are of industry, and can kind of share back, since there's such greater participation in standards from industry than there are from government. The other thing I would say is that I do think we're in an interesting opportunity coming up hopefully soon, which is that during the pandemic, we've really seen access to some of the SDO processes greatly expanded because we've all been remote and nobody is getting on airplanes to travel. And we know that lots of work can happen when we're not in meetings, but a lot of work does happen at the meetings themselves. And so virtual meetings have kind of leveled the playing field in terms of access. And I think as we start to return to some travel and we look at hybrid meetings, and there's some organizations that have already started this, there's a big question out. We maintain some of those aspects of level playing field, and how do we continue to support those who are in the hybrid mode, who are remote, but who want to continue their involvement that maybe started during the pandemic. I think that's a big operational question for SDOs and other technical organizations, and there's going to be lots of experimentation and mistakes and triumphs there. But that, I think, is a big opportunity in terms of opening more access to these fora.
Lisa, please.
A quick comment, because I must say I agree with Alyssa. This is not to be a government-led process. That's not my aim here. It's more, we need the communication to happen at an earlier stage, because often it's happening when any technical standard has been developed, and then it's too late, in my opinion. You need to actually to relate and discuss at an earlier stage. And I must say, I have seen examples of bad regulation happen in Europe because they didn't understand the technological underlying fundament of what they were regulating. So to me, having that understanding, I think, would save us a lot of trouble also in the future. And that's why I'm thinking the more involvement at an earlier stage, the better we will be. But still, I agree. An industry-led standardization is preferable.
If I can add on the inclusiveness side, also not to forget the developing countries, developing world, and there have been reluctant participants perhaps in the past, but I think there is a desire to be more engaged. Also seeing that such proposals can directly impact the investment that have taken place over the years in developing countries. So getting more inclusive in terms of bringing developing countries in the picture, helping making standards collectively, I think would be also very, very, very useful. Thank you so much. Really, maybe I can give 30 seconds to each for concluding remarks before we conclude. Alan, I will start with you, please.
Thank you, Hussein. Well, I would just like to thank you for the opportunity to talk today and to share some of our ideas. I think the internet is not 40 years old, it's 40 years young. And there are a lot of things that we can still do.
Alisa, please.
Yeah, it's been a great discussion, and I'm just, to continue the collaboration in support of this, unbelievable feat of engineering that we all enjoy every day, and that will hopefully continue to connect more and more of us across the globe as we go forward.
Thank you. Lisa, please.
From my side, thank you for some very insightful debate. I think this debate also shows that we are starting to discuss all these issues that are important also for the future of the internet. IGF is an excellent example. We just need to make sure IGF also trickles down into the SDOs, and it's important we have that crossover. But having Alain and Alyssa here showing that it is happening, that crossover too.
Thank you so much. Really, these are very, very important and critical remarks and interventions. I'm very happy that we got together and look at the future of the internet. We're appreciative to the UK IGF and to DCMS to put this together. And with this, I'll turn it back to our host, Desiree, please. The floor is yours. Thank you so much. Thank you.